Rosemont Copper Company, building a bridge to a sustainable future. When it comes to environmental performance, protection of the water resources surrounding the Rosemont facility is a primary concern. Rosemont Copper's strategy for this protection consists of a three-point plan: control, management, and containment of internal and external water flow. Rosemont Mine's processing facility area, or footprint, is half the size of similar mining operations. This design will assist in the facilitation of the control and management of free-flowing water. Diversion channels will be designed, engineered, and constructed to control the flow of the rainwater and runoff. These channels will divert runoff around and away from the plant operations. To manage stormwater runoff on the surface of the waste rock and dry stack tailings area, detention basins have been designed. These basins are engineered to collect and retain water, which will help to minimize erosion and aid in revegetation of the outer surfaces. A series of flow-through drains will be constructed throughout the dry stack tailings area. Unimpacted water flow from the Beryl and McCleary canyons will be allowed to flow downstream. Water that falls on the processing facility will be retained and utilized on site. Rosemont Copper's facility will operate two independent closed-loop water systems. The first system will process copper sulfide ores in the production of copper and moly concentrates. A series of crushing, grinding, and flotation processes will culminate at specialized filters, which will recover and recycle approximately 90% of the water used in this system. The second system will use oxide ores in the production of copper cathodes. It will use a heap leach circuit layout, which will reuse and recycle system water. The application of modern containment technology will be used in the construction of water impoundment areas, such as the PLS and raffinate ponds. The heap leach pad operation will minimize evaporation, resulting in lower overall water consumption. The industrial science behind these technologies will contribute to the success of Rosemont Copper's water conservation program. The dry stack tailings system eliminates the need for ponds and minimizes the possibility of subsurface water seepage. Dewatered tailings will be delivered by conveyor belt to a storage area where they will be deposited by a radial stacker, then spread and compacted to form an unsaturated dry stack tailings facility. During operations, a cone of depression will form around and away from the pit. This cone of depression does not cause any effects to Cienega Creek. The open pit will receive incidental rainfall and groundwater. This water will be pumped to the process circuit and could reduce the demand on pumping wells located on the west side of the Santa Rita Mountains. The chemistry of the water accumulating in the pit during and after operations will be similar to local groundwater. The open pit will begin to fill with water after the end of mining and pit dewatering. Groundwater and surface water will contribute to the pit water. Water will not leave the pit except through evaporation. Modeling has predicted that the cone of depression caused by pit dewatering will expand outward until steady-state conditions are reached. Because the pit will always be a cone of depression or hydraulic sink, none of the water in the pit will escape. This protects the quality of the aquifers downstream of the facility. Between 700 to 1,000 years after mining operations have ceased, the pit water will reach a depth of approximately 1,279 feet. Rosemont Copper will use innovative engineering and advanced technology to protect and conserve the water in and around their plant and facility operations. The protection and conservation of the water in and around the Rosemont Copper facility is a top priority. Rosemont Copper Company, building a bridge to a sustainable future. For more information, please visit our website at www.rosemontcopper.com.